So today's topic is the vertical motion. Vertical motion, or in some books they have mentioned this topic as motion under gravity. Either you can call it as a vertical motion or you can call it as motion under gravity. So don't get confused with these two topics names. Okay, so we are discussing in today's class the vertical motion. Now, so this is the vertical motion what we are going to study in today's class. See students, before going for the vertical motion, you should have the concept of acceleration due to gravity. What is acceleration due to gravity? So this acceleration means, I suppose I make any object and I just leave it. So what happens? Because of the gravity, it falls down. So there will be some acceleration produced in the body. That acceleration with which that body is moving down, that is towards the earth's surface, that acceleration we call it as acceleration due to gravity. I repeat once again, when you leave a body, it will fall down with some acceleration. That acceleration we call it as acceleration due to gravity. So how you are going to define this acceleration due to gravity? Acceleration due to gravity is the acceleration produced in the freely falling bodies. Just एक freely falling body का जो acceleration होता है ना बेटे, उसको हम बोलते हैं acceleration due to gravity. Let us see. Acceleration due to gravity. So acceleration due to gravity. What is this acceleration due to gravity? Acceleration produced. Acceleration produced in the freely falling body. So acceleration produced in the freely falling body is called as an acceleration due to gravity. Okay. So this is the definition for acceleration due to gravity. Now let us come to the value for acceleration due to gravity, because most of the students they get confused what to take and when to take the value for this. Okay. So acceleration due to gravity is 9.8 meters per square second. And next, this acceleration due to gravity is given as 980 centimeter per square second. This is the value in SI system. This is the value in CGS system. I hope it is clear. Okay. So this is the value in SI system and this is the value in CGS system. So this is 9.8. Sometimes based on the calculation of the problem, you may take this 9.8 as 10 also. Students, I repeat, based on the complexity of the problem, we can change the value of G. Either you can take it as 9.8 or you can take it as 10. Sometimes we take 9.8 based on the problem. Sometimes we take 10 based on the problem itself. Okay. Whichever the value if you take and the problem is becoming easier, we take that value. Okay. तो यहाँ पे आपको ये नोट करना है बेटा, इसको नोट कर लीजिए, then I'll move fast. Gravity. So motion under gravity means that is a vertical motion. So in this, what we are going to study? We are going to study what in vertical motion, two types of situations. What are the two types of situations? The body may go up, that is also vertical motion. While going up, the body may go up, that is a vertical motion. The body may come down, that is also a vertical motion. So under this situation, we have to study the two cases. That is first one, when the body is somewhat freely falling or coming down, or second situation when the body is projected vertically upwards. So the first one, I'm writing it as equations. Try to understand first. Equations of motion for freely falling body. बेटा फ्रीली फॉलिंग बॉडी के लिए हम इक्वेशंस ऑफ मोशन लिख रहे हैं. व्हाट आर दीस इक्वेशंस ऑफ मोशन एंड हाउ टू राइट इट? सी what I suggest always, students, no need to mug up all the formulas. Just try to get the situation, try to get the concept. That is very important for you, rather than just remembering and mug upping the formulas. ठीक है. तो बेटा यहाँ पे हेडिंग में क्या लिखा हूँ देखिए अब आप. Equations of motion for freely falling body. Freely falling body का मतलब क्या होता है वो सोचिए पहले आप. I'm making one body, I'm taking one body and I'm just leaving it. So it will fall down. Am I applying any velocity? Am I giving any velocity to that object? No, I'm not giving any velocity to that object. So what is the velocity of that particular object? Initial velocity of that particular object is 0. तो यहाँ पे हमारे को एक कंडीशन मिल गया बेटा, इनिशियल वेलोसिटी क्या हो गया, 0 है. द फर्स्ट वन, इनिशियल वेलोसिटी इज 0. द सेकेंड वन, whenever the body comes towards the earth, you have to take acceleration always positive. आपको क्या करना है, acceleration positive ही लेना है बेटा. When the body is coming down towards the earth, जब earth towards the कोई object towards the earth move होता है, you have to take a always as plus g. That is you have to remember. ठीक है. Now बेटा अब आइए equations of motion लिखते हैं. For the equations of motion for the freely falling body I am writing. So first equation what I have written yesterday I am writing once more time. V is equals to u plus at. The second one equation, s is equals to ut plus half at square. The third one, v square minus u square is equal to 2as. The fourth one, Sn is equals to u plus n minus half into a. V is equals to u plus at, S is equals to ut plus half at square, v square minus u square is equals to 2as, and Sn is equals to u plus n minus half into a. You might be thinking, why sir has not written the fifth one? If you check the fifth one, beta, check fifth one, check करके देखिए आप. What is that fifth one? S is equals to u plus v by 2 into t. There we don't have any acceleration. There we don't have any acceleration. That's why I'm not considering that equation, because this is the equations for the freely falling body. In short, I can say this is the vertical motion or motion under gravity. This is the motion under gravity. Means what do you mean by that motion under gravity? We have to take care about the acceleration as acceleration due to gravity. So यहाँ पे fifth one I'm not taking the fifth one, because in the fifth equation I don't have acceleration term. चलिए बेटा फर्स्ट इक्वेशन में लिखता हूं. हाउ टू राइट दिस फर्स्ट इक्वेशन फॉर द फ्रीली फॉलिंग बॉडी के लिए. फर्स्ट इक्वेशन क्या फॉर्म लेता है, व्हाट द फॉर्म इट द फर्स्ट इक्वेशन टेक्स फॉर द फ्रीली फॉलिंग ऑब्जेक्ट. तो आइए, इनिशियल वेलोसिटी इज 0, एक्सेलरेशन इज प्लस जी. इस इक्वेशन को लिख रहा हूं बेटा. v is equals to, what is this u? U is 0, this is 0, leave it. So what it becomes, just gt. Beta a, in place of a I have to write g into t. That is first equation for the freely falling body. Now it is becoming v is equals to gt. Again I stress on my previous statement, don't try to mug up the formulas, don't try to learn the formulas. You should know the concept better, because if you know the concept you can solve any type of question given in the paper. But अगर आप सिर्फ याद करते हैं ना, याद करने से वो पर्टिकुलर सिचुएशन में वो फॉर्मूला यूज करना और वो चीज आपको याद आना और उस चीज को आप अप्लाई करना, दैट इज वेरी डिफिकल्ट. दैट इज वेरी वेरी डिफिकल्ट. So therefore what I suggest, just try to remember the concept what I am teaching. ठीक है. The second one बेटा, see the body is coming down, right? This object is coming down. This object is coming down, so it is falling. Suppose how much height? Height I'll take it as h. I'm taking the height h. So this displacement will be a vertical displacement. So therefore I take this is h is equals to this. Again initial velocity will be 0, half. This is a is nothing but g. This is g. This is t square. This is t square. Next come to the second situation. Third one, that is the third equation. What it takes the form? देखिए बेटा, this is v square. This is v square. Initial velocity again it is 0. What it becomes, that is equals to 2. In place of a I have to write g. I hope you are getting. In place of a I have to write g, and in place of s, this is the displacement. I want to write it as a vertical displacement h. Next, this equation, this one, this is the displacement covered in the nth second. So I can take displacement covered, that is a vertical displacement in the nth second. So this part will become 0 plus, that is equals to, this is 0 no, so I can take n minus half into, this is what beta, g. So if you know the logic, then 100% you are going to get the formula. ठीक है, please copy it. Time of ascent. What is this time of ascent? टाइम ऑफ एसेंट मींस, एसेंट का मतलब ही होता है बेटा ऊपर जाने के लिए हम एसेंट का वर्ड यूज करते हैं. When something comes down, no, descent का word use करते हैं. So this time of ascent means the time taken by a body to reach the maximum height. एक ऑब्जेक्ट को मैं ऊपर प्रोजेक्ट करता हूं, तो व्हाट हैपेंस टू दैट ऑब्जेक्ट? द बॉडी विल गो अप 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 एंड एट द सेम टाइम इट रिटार्ड्स. दैट मींस उसकी वेलोसिटी क्या होने वाली है बेटा? जीरो एट एनी मोमेंट बन सकती है. कब? उसकी वेलोसिटी डिक्रीज होंगी तब. ठीक है. सो व्हेन यू आर प्रोजेक्टिंग द बॉडी अपवर्ड because of acceleration due to gravity, that body will get pulled down, but it is going up. So एक ऐसा situation आता है बेटा जहां पे उसकी final velocity क्या होती है? Zero हो जाती है. So let us go for the situation. The body is projected up. So initial velocity, यहाँ पे some initial velocity will be there. This is initial velocity. This is projected up. So upward motion है, तो A is क्या रहेगा बेटा हमारे लिए? Upward. The body is going moving away. When the body is moving away, A is can be written as minus G. And at the maximum height, इसकी velocity कितनी है बेटा? Zero. At the maximum height, its velocity is zero. So I want to calculate the time of ascent. मतलब कितना time लगा है? How much is the time under this situation? कितना time है? Suppose the time is T1 I'll take. How much is the time the body takes so that it will be reaching the maximum height? तो कैसा करेंगे हम यहाँ पे? देखिए, I have given you the first equation. V is equals to U plus AT. बेटे, I am not going for the equations what I have derived and what I have shown you. Because if I start using the derived equations what I have shown you, then again it will be a somewhat difficult. It will be somewhat difficult for you to again understand. मैं basic equations पे ही बात करूंगा. Then what was the necessity that I have shown you? The necessity was that was an application part. How to apply and how to take, that was very important. हम उस equations को हम याद नहीं रखेंगे, बता रहा हूं मैं आपको. ठीक है, चलिए. At the maximum height, what is the final velocity बेटे? Zero. ये final velocity zero. Now, initial velocity. What is the initial velocity? Initial velocity is U. The body is moving upward, so therefore it is minus G into T1. A can be written as minus G. Now, I take this term this side, so what it becomes? G T1 is equals to U. So T1 is equals to U by G. T1 is equals to U by G. So this is the time of ascent. And you know, students, in vacuum, whenever the body is projected upward, it takes some time to reach the maximum height. And it takes the same time to come down. अगर 2 seconds ऊपर जाने के लिए लगता है बेटा, तो 2 seconds नीचे आने के लिए भी लगेगा. So what I do, I'll write side by side here. Time of descent. So this time of descent, try to understand what is this time of descent. Time of descent is the time when the body is coming down. नीचे जब आएंगी from the same maximum height, when it comes down, no. So that time we call it as time of descent and we take it as T2. और यहाँ पे हम क्या लेंगे बेटा? A is equals to plus G. Under this situation, I am not deriving the equation because this is not the time to complete all the derivations. Just we are going for the competitive level. So in vacuum, when the body is projected upward, it takes some time and it takes the same time it to come down. So देखिए, so it is T2 is equals to U by G. We are getting T2 is equals to U by G. लेकिन एक चीज याद रखना है बेटा, T1 is equal to T2. T1 is equal to T2. That is time of ascent is equal to time of descent. Try to understand. Time of ascent is equals to time of descent. कब? In vacuum. This is very important. लेकिन what happens students, like in air, general अगर आप गौर करेंगे, general अगर आप गौर करेंगे, मतलब प्रैक्टिकल एग्जांपल में जब देखेंगे, where air is there, तो टाइम ऑफ ascent is more और टाइम ऑफ descent is more. यहाँ पे I have given you condition, टाइम ऑफ ascent is equal to टाइम ऑफ descent only in case of vacuum. जब आप एयर रेजिस्टेंस कंसीडर करेंगे ना बेटे, तो कौन सा टाइम बढ़ के रहेगा? टाइम ऑफ ascent बढ़ के रहेगा, ऊपर जाने का टाइम बढ़ के रहेगा, या नीचे आने का टाइम बढ़ के रहेगा? तो स्लाइट कंफ्यूजन विल बी देयर. I'll just to avoid that confusion, I'm giving one example. You take one feather, एक छोटा सा पंख लीजिए, पंख लेके इस तरह से रख के बेटे उसको आप जस्ट ब्लो करिए एयर में, तो व्हाट हैपेंस? दैट फेदर विल गो अप विद इन 1 सेकेंड. ऊपर जाने के लिए 1 सेकेंड लगा. जस्ट इमेजिन, 1 सेकेंड ऊपर लगा, ऊपर जाने के लिए 1 सेकेंड लगा. वही पंख जो है ना बेटे, नीचे आने के लिए इट विल स्लोली इट विल कम डाउन. नीचे आने के लिए स्लो हो जाता वो, नहीं? तो ऊपर जाने के लिए 1 सेकेंड लगा, नीचे आने के लिए एटलीस्ट इट विल बी टेकिंग 3 सेकेंड्स। तो अब यहां से ये एग्जाम्पल से, प्रैक्टिकल एग्जाम्पल से हमारे को ये पता चल रहा, जब एयर रेजिस्टेंस हम देखते हैं, एयर रेजिस्टेंस को कंसीडर करते हैं, तो टाइम ऑफ डिसेंट बढ़ जाता है। फिर से मैं बता रहा हूं, पंख है बेटा, फेदर है, उसको हम प्रोजेक्ट कर रहे हैं, ब्लोइंग कर रहे हैं, तो ये ब्लो कर से फटाक से ऊपर जाता, राइट। ऊपर जाने के बाद इट कम स्लोली स्लोली नीचे आता। ऊपर जाने के लिए 1 सेकेंड, नीचे आने के लिए 3 सेकेंड्स लगे सपोज, तो हम वहां पे उस सिचुएशन में ये बताते हैं टाइम ऑफ डिसेंट इज मोर देन द टाइम ऑफ एसेंट। तो वो भी लिख देता हूं मैं, T2 इज ग्रेटर देन T1। टाइम ऑफ डिसेंट बढ़ जाएगा बेटा कब, when we are considering एयर रेजिस्टेंस, एयर रेजिस्टेंस जब हम कंसीडर करेंगे। इज इट ओके? अब आइए बेटा, नेक्स्ट टॉपिक वी आर गोइंग फॉर, दैट इज टाइम ऑफ फ्लाइट। टाइम ऑफ फ्लाइट मीन्स टाइम for which body remains in air। टाइम फॉर विच द बॉडी रिमेन्स इन एयर, ऐसे टाइम में बॉडी जितनी देर एयर में रह रही है बेटा, उस टाइम को आप बोलेंगे टाइम ऑफ एसेंट। कितनी देर एयर में रहेंगे, द बॉडी को हम प्रोजेक्ट करें, ऊपर गया, बॉडी ऊपर गया, रीचेस द मैक्सिमम हाइट एंड अगेन इट हैज कम डाउन। तो कितनी देर तक जो बाहर, कितनी देर तक एयर में रहा बेटे, उसको हम बोल रहे हैं टाइम ऑफ फ्लाइट। तो टाइम ऑफ फ्लाइट कैसे कैलकुलेट करेंगे, ये ऊपर गया टाइम ऑफ एसेंट, फिर ये नीचे आया टाइम ऑफ डिसेंट, तो टाइम ऑफ एसेंट प्लस टाइम ऑफ डिसेंट को ऐड करेंगे हम। चलिए आइए, सो दिस टाइम ऑफ फ्लाइट इज नथिंग बट टाइम ऑफ एसेंट प्लस टाइम ऑफ डिसेंट। दिस इज u by g। बेटे ये भी तो u by g है, so therefore g is the LCM, u plus u that gives us 2u। कॉपी कर लीजिए फास्ट।